Okay, today I'm going to review over derivatives of inverse trig functions, section 3.8. I'm only going to do 3 of them. There are 6 inverse trig functions. I'll do 3 of them, and the remaining 3, you can see how they are related to the ones that we're going to do, and you're also be responsible for knowing all of them, actually. Okay, so here's our inverse trig function, y equals to the inverse sine of x. Please remember that that is also the same thing as saying y equals to arc sine x. And basically, I want to find the derivative of it. I want to find dy dx, or the derivative with respect to x of the inverse of sine x. Now I'm going to show you guys how to derive this because chances are you have forgotten what the derivative of the inverse sine is. So what we're going to do here first is to rewrite this inverse trig equation, or inverse trig function, as x equals to sine y. And then we're going to differentiate implicitly. So differentiating implicitly gives us derivative of x with respect to x is going to be a 1. And then we have derivative of sine y. What is the derivative of sine y? That is cosine y, and then you need to have a dy dx also. So this dy dx is the same dy dx that we're looking for, so we need to solve for that. So I can solve for dy dx by dividing both sides by cosine y, which is going to leave me with secant y. But now I'm trying to find the derivative with respect to x, and I want my answers in terms of x. So although this is great, secant y, I need to give my answer in terms of x. So how do we switch that over? What you're going to need to do is draw a triangle. So let's take a look at what x equals to sine y would represent in terms of our triangle. That means that we have some angle y whose sine value is x, or x over 1, because sine represents opposite over hypotenuse. The opposite side is x, the hypotenuse is 1, so you can determine the missing side by using the Pythagorean theorem, so in this case square root of 1 minus x squared. So if I were to try to figure out what secant y is, well, this is our angle y in our triangle, so I want secant of this triangle, which is going to be the reciprocal of the cosine. So what do you have for that? That's going to be 1 over square root of 1 minus x squared. This is the derivative of inverse sine x. So now I'm going to repeat this and do this one more time, but instead, or something similar, but I'm going to find dy dx for y equals to inverse cosine x. So let's see if you can follow the same sort of process as we did up here on this first example. Okay, so let's try first to see what we have to do. First thing we need to do is rewrite this so it says x equals to cosine y. And I'm going to go ahead and draw my triangle already. I have some angle y where the cosine value is x over 1. So cosine is adjacent over hypotenuse, and then my other leg is the square root of 1 minus x squared. Okay, so now let's differentiate implicitly. The derivative of x with respect to x is 1. The derivative of cosine y with respect to x. Do you guys remember what the derivative of cosine y is? It's negative sine y. Don't forget your dy dx. So that means dy dx equals to negative 1 over sine y, or negative cosecant y. So again, we want to write our answers in terms of x. So the derivative of inverse cosine of x is going to be negative cosecant y. Cosecant is the reciprocal of sine, which is opposite, hypotenuse over opposite. So 1 over square root of 1 minus x squared. Notice the similarity in this derivative compared to the first one. They are negatives of each other, so they are related. The sine and the cosine derivative go together, and can you guess which other ones go together? The tangent and cotangent, and the secant and cosecants. So the only other one I'm going to do with you guys, I'm going to do half of the 6. We are going to find what it is for inverse secant x. So when y equals to inverse secant x. Okay, so this is our last one. Hope you guys are following along okay. So the equivalent other statement for y equals inverse secant x is x equals to secant y. I'm going to draw my little triangle right here. So secant is the reciprocal of cosine, so now I have hypotenuse over adjacent. But now because this x value can be negative and I need to draw my triangle so that I have a hypotenuse that is always positive, I'm actually going to throw in an absolute value of x over here. So that this becomes square root of x squared minus 1. Okay, so unless I tell you already that x is positive, we want to make sure that you don't have a hypotenuse that's going to be negative. Alright, so let's take the derivative of this. The derivative of x with respect to x gives us 1. Now the derivative of secant y. You guys remember the derivative of secant? It is secant tangent, then our dy dx. Which means dy dx is going to equal to, when you divide by secant, you get a cosine. When you divide by tangent, you get a cotangent y. Now let's take to our triangle again. The derivative of inverse secant x. Cosine of y. Oops, I forgot to label my triangle with an angle y. So cosine is 1 over the hypotenuse, which is absolute value of x. And then cotangent is adjacent over opposite, which is 1 over square root of x squared minus 1. So here's our third one. I'm going to leave the other 3 for you. Now for your homework, when you work on these, your assignment tomorrow, you don't need to go through the derivations of these over and over and over again, unless you really want to and make your homework assignment a little bit longer than it is. You just need to apply the formulas that you use for the derivatives, just like you would memorize the derivatives of natural log and cosecant and secant and e to the x and so on. You just use them and use the chain rule with them. So there will be a lot of chain rule on your homework. Okay, see you guys tomorrow.